Right. So, in photochemistry, in your last class, we discussed about photochemistry of olefin. All possible applications we discussed. So, cis-trans isomerism. Then we also discussed photocyclodimerization, photocycloaddition. In the same way, we also discussed simple addition and cross addition. So, that is end of photochemistry of simple olefin. Next, photochemistry of 1,3 butadiene. Keep reading. Photochemistry of 1,3 butadiene. More than one double bonds, photochemistry. So this is called 1,3 butadiene. 1, 2, 3, 4. Now normally see, if I convert like this, this is called cis-trans isomerism, 1,3 butadiene. Okay. So normally this is called cis 1,3 butadiene, and what is this? This is called trans 1,3 butadiene. So thermally it is possible, but photochemically not possible. Thermally we can convert cis isomer to trans isomer. Means I can rotate this bond, and I can rotate this bond to get this one. But same molecule, if I take photochemically, this is photochemical interconversion. Photochemical interconversion not exist. Photochemically we can't convert cis isomer to trans isomer. But what about simple olefin? Simple, yesterday starting class, simple olefin under photochemically we can convert into cis to trans. Thermally not possible. But diene chemistry, thermally we can convert, but photochemically not possible to convert. This point is key point. Ground state we can convert cis to trans, but excited state we can't convert cis to trans. Okay. Remember, this is called C2 carbon and this is called C3 carbon. C2 carbon, C3 carbon having a single bond. So under thermally we can rotate this CC bond. But whenever if you irradiate with suitable light, this C2, C3, 1, 2, 3, 4. C2, C3 carry double bond character when you excite them. If you irradiate with suitable light, C2, C3 carry double bond character. When they get double bond character, this double bond is unable to rotate. So that's why photochemically not possible. Photochemically, cis never converted to trans. Conjugate cis I am saying. Now two double bonds same side or not? Cis. Now here opposite side. Photochemically cis never convert to trans because photochemically it is excited. When they excites, single bond starts converting into double bond. So once this single bond starts converting into double bond, it is impossible to rotate. Excited state, it is impossible to convert. Ground state, it is possible to convert. Clear? Take this. So it is impossible to convert under photochemically. Right. 1,3 butadiene is liquid at room temperature and available mixture of cis and trans isomer. So cis trans isomers are available. Cis and trans isomer available in mixture of cis and trans isomer. One comma 3 butadiene is, it is a liquid at room temperature and we can have a mixture of cis and trans at equilibrium or at room temperature. These two are at equilibrium. Cis and trans isomers are in a reaction mixture. They are readily exist in the form of equilibrium mixture. See, at ground state, they are interconvertible. They are interconvertible. Why they are interconvertible? due to C2C3 single bond character. Due to C2C3 single bond character, they having a C2C3 single bond character and develop dynamic equilibrium. So they will develop a dynamic equilibrium between them. So there is a dynamic equilibrium establishes between cis and trans at ground state. This point is very important. They are liquid at room temperature and cis and trans isomers are exit at room temperature only at ground state. Ground state nothing but thermal or photochemical? Thermal. Only at ground state they are interconvertible. Why they are interconvertible? Interconvertible means cis I am converting into trans. Trans I can convert into tris. And why they are interconvertible? Because they are having a single bond character. Between this C2 carbon, C3, it is a real single bond. Under thermally, under ground state. They never converted double bond when you supply heat energy. When you supply heat energy, this molecule taking heat energy, this single bond is single bond only. They never changes to double bond. So if it is a real single bond, can I rotate like this or not? Yes, so that's why thermally we can interconvert. This is called interconversion. But when you take photochemically, this energy once if they transfer to this particular molecule, this C2C3 single bond starts converting into double bond. When this molecule takes energy, this single bond starts converting into double bond in excited state. That's why it is can't be rotatable. If it is unable to rotate, can you prepare trans isomer? No. So that's why thermally diene interconversion possible. Photochemically diene interconversion not possible. This question regularly they are asking. Simple olefin cis trans possible under photochemically, but conjugate olefin cis trans isomerism possible under thermally. Clear? This point you need to remember. Normally cis trans isomerism possible under photochemical, but only for simple olefin having only one double bond. See, if molecule having only one double bond, we can convert them into cis and trans under photochemical. Yesterday we discussed this one, 330 nanometer steel beam. So this we can convert into trans isomer under photochemically. But this isomer never converted to trans isomer under photochemically. It is possible under ground state. Ground state nothing but thermal. So is it cis trans isomerism possible for excited state for this molecule? No. Excited state this molecule never give cis trans isomer. Only ground state interconversion possible but not excited state. Ground state nothing but thermal, excited state nothing but photochemical. Okay. See, at ground state 95% of trans isomer and 5% of cis isomer. Cis isomers are isolated. So what is the percentage of trans isomer in ground state? Ground state trans isomer is 95%. And what about here? 5%. 5% trans isomer or 6%. 5 is cis, 95 is trans. So which is more stable between cis and trans? Trans is more stable. Percentage of trans is greater as compared to percentage of cis. Okay. So now I am writing at excited state. Excited state nothing but photochemical state. This is thermal state. Excited state after absorption of light C2C3 bond, C2C3 bond partially develops double bond character. Partially develops double bond character and interconversion not exists. And interconversion does not exist. So which interconversion not exist? Which interconversion not exist? Cis trans interconversion not exist at which state? Excited state. When diene absorbs light energy, after absorption of light energy, C2C3 will be get excited. C2 C3 will develop a double bond character. After getting double bond character, impossible to interconvert. So this is not single bond. Right now C2 C3 bond. This C2 C3 bond start converting into double bond. Partially develops double bond character. Due to that, it is impossible to rotate. So which means if I take a diene, this diene initially shows a double bond character like this. This is 1, 2, 3, 4. Photochemical excited. Now this is a double bond character. Photochemically it is impossible to convert because it is showing double bond character. It is diene or simple olefin. It is a diene. It is a diene. This I am saying. C2 C3. 1, 2, 3, 4. Okay. See, when I take diene like this, if it is absorbs light energy, if they absorbs light energy, what happens to this internal? Internal carry double bond character. See, a double bond character is 0 not. So this interconversion is not exist, so we can't prepare trans isomer. So which means initially single bond is there here, but right now it is C2, C3 showing. See, dots and normal line is there. So it is showing partial double bond character. So that's why rotation not exist. So excited state never converts into trans isomer. So photochemically simple olefin interconvertible, but thermally conjugate olefins can be interconvertible. See, simple olefins at ground state or excited state, simple olefin at excited state, and conjugate olefins. I am taking conjugate olefins and conjugate olefins at ground state. Ground state nothing but thermal or interconvertible. So you need to remember this point both for simple olefin and conjugate olefin. Simple olefin photochemical, but conjugate olefins thermal, they are possible. Which means I can say like this: I want to convert this cis isomer into trans isomer. What is the condition required? I want to convert cis to trans. What is the condition required? Photochemical. Okay, but same cis olefin, I am writing same cis olefin. Same cis olefin I am converting into trans olefin. This is possible under. Now this is thermal. These are two questions which they are asking every time in exam. Cis trans isomerism interconversion depends upon the condition and depends upon the molecule. If it is a normal olefin, only double bond responsible for cis trans isomer. On that time use photochemical condition. See, is it double bond responsible to give trans isomer? But right now single bond responsible to give cis trans isomer. If double bond is responsible to give cis trans isomer, apply light. So when you apply light, double bond becomes single bond. When you apply thermal, single bond is as it is, ground state, we are not changing. So it can be interconvertible. So these 2 points you need to remember. Which among the following is a suitable condition? Like that they will ask. At ground state, this will develop a single bond character between C2, C3. At excited state, this will develop a double bond character. Once if they develop double bond character, interconversion not exist. So now diene having two characters, singlet and triplet. So I can say singlet photochemical reactions are differ over triplet photochemical reactions. So what about reaction exit state? See 1,3 butadiene having two reaction exit state, pi to pi star singlet and what is one more, pi to pi star triplet. So is it efficient IS or inefficient ISC? Is it conjugate diene efficient or inefficient? Inefficient. So I can say conjugate diene, it is inefficient ISC. It is a inefficient ISC molecule. Means can you generate pi to pi star triplet? Is it possible to generate pi to pi star triplet? No. So this molecule 1,3 butadiene never convert trans isomer under photochemically. Right? They never undergo excited under photochemical. We can't interconvert. Now my question is, excited state is pi to pi star triplet, pi to pi star triplet. This is never giving ISC. They never give triplet state. But we want a triplet state because singlet reactions are differ over triplet reaction. This molecule have a tendency to give two different products with singlet and triplet. But they never generate triplet state. So can you generate triplet state by using triplet sensitizer? Yes. So in order to get triplet product, they required a triplet sensitizer. This is a common state. Most commonly this molecule will give pi to pi star singlet. But not easy to give pi to pi star triplet. They never give pi to pi star triplet directly. Direct irradiation will give singlet. Triplet sensitization will give triplet. Okay. This is not possible to generate by using diene. Diene never give pi to pi star triplet. Because large energy gap between singlet and triplet, it is inefficient. So this ISC never converted to triplet. So that's why in order to generate the triplet state, there is a requirement of a triplet sensitizer. Okay, it is inefficient ISC molecule. See, they require triplet sensitizer for pi to pi star triplet generation. But still I want to generate pi to pi star triplet. They require a triplet sensitizer. So what are the most common triplet sensitizers? So take benzene, toluene, xylene, benzophenone, etc. Aromatic caramel compounds, aromatic skeletons are triplet sensitizers for this one. Diene is inefficient ISC molecule. They never generate triplet state, but triplet reactions are different as compared to singlet. So in order to generate triplet state, there is a requirement of a triplet sensitizer. Over. Now see the reaction involved in this one. See, I am writing 1,3 butadiene like this. So it is a mixture of two isomers. Cis and trans both are present in this one. Photochemically direct I am using direct product. So here you may expect a dimer, a bicyclic compound and less than 10% of dimer. So these two are major. When I take 1,3 butadiene direct irradiation, what is direct irradiation? Pi to pi star singlet or triplet? Singlet. When pi to pi star singlet is excited state for diene, we are not doing cis trans isomers. So on the time, this product and this product is possible. There is no dimer product. Dimers are possible under triplet state. Now same reaction I am writing, but I am taking a triplet state. Cis and trans isomers both are possible. Now here I am using triplet sensitizer. Photochemically triplet sensitizer I am using. Then variable products are expected. See, this is a trans isomer, one product, trans 1,2 divinyl cyclobutane, cis 1,2 divinyl, then followed by 4-vinyl cyclohexene. This is the answer. These all are dimers. Dimer and this is dimer. Dimer formation not existed, singlet state. Dimer formation possible only at triplet state. Pi to pi star triplet, dimer formation is exist. So this is called 1,2 divinyl cyclobutane. This is a trans isomer. 2. One bond above, one bond below. Now same, name is same, but it is a cis isomer. Name is remain same. 1,2 divinyl cyclobutane, and it is a cis isomer. So one bond is above and one bond is below. See how my hand is going on. Above, cis. It is a cis isomer and this is trans isomer. Now this is called 1, 2, 3, 4. It is very, very important. 4-vinyl cyclohexene. 4-vinyl cyclohexene. This will decides, always remember which is major. Trans is major. Always this is major. Okay? These two are minor. This percentage is decreased by this formation. If this formation increases, this percentage decreases. Okay? Right. Two reactions we are learning now. Singlet reaction and one more is triplet reaction. Singlet you will get normal single molecule interconversion. But whenever if you take triplet molecule, you will get a 1,2 trans divinyl cyclobutane, cis 1,2 divinyl cyclobutane, 4-vinyl cyclohexane. Now we are discussing this one first. First, how you will get singlet products, then how you will get triplet products. So 1,2 divinyl cyclobutane and this isomer is cis isomer. 4-vinyl cyclobutane, 4-vinyl cyclohexene, it is always minor. These two are always minor, this is major. Always trans is major in this one. Especially if reaction exit state is what? Triplet. Singlet products are different, triplet products are also different. Based on the reacting molecule, you need to change the answer. See, if I take a cis 1,3 butadiene, can I take like this, cis? So what is the state here? Ground state. Photochemical if I excite it, then what is the state you are going to expect? S1 state, singlet or not? Pi to pi star singlet. Then what happens? See, this will undergo this reaction. So what is this reaction? This will give this particular reaction, you will get this answer. What is this? Electrocyclization, pericyclic reaction. What are the two isomers present for 1,3 butadiene? What are the two isomers? What are the two isomers are possible for 1,3 butadiene? Cis isomer, trans isomer. So photochemical when cis is activated, you will get S1. S1 responsible for this product. See, I given two products. One is a bicyclic compound, other one is cyclobutene. Cyclobutene produced by activation of cis isomer. So this is an example of electrocyclization. And if I take trans isomer, see this is a trans isomer, initially S0, photochemically I can make them into S1. See this is S1, excited. Now this is responsible to give one new product. Okay, so here if this carbon join together, right? See, this carbon join here, this carbon join here, then what happens? You will get this kind of product. See, I am writing like a Z structure. Now this is combining here, this is combining here, right? See, bond present here, it will attack here, then bond present here, it will attack here. 2 pi 2 pi cyclation photochemically, two independent pi bonds. Now it is a bicyclic compound. Okay, so this is bicycle, so I can say bicyclo. Left side one carbon is there 1, right side one carbon 1, between these two no carbon, that is 0. So this molecule can I write like this? It is a bicyclic compound, left side one ring, right side one more ring. Left side ring carry one carbon, right side ring carry one carbon, between these two no carbon, 1 1 0. Total how many carbons are there? 4, 1 2 3 4. So I can say butane. That is the answer. So when you excite in singlet state, you will expect a single molecule product, but there is no dimer. So two units never undergo, get combined together, and they never give dimer product. Dimer product not exist in singlet state. Is two partners are combining now? No, two partners are never combined in this one. Okay, dimer product percentage is very less. So we can ignore that 10%. Only 10% is possible. When cis excites in singlet state, you will get cyclobutene. When trans excite in singlet state, then you will get a bicyclic compound. Bicyclic compound produced by a trans isomer, cyclobutene produced by a simple olefin, cis isomer. So this is cis excited and here trans excited. So this is cis olefin, ET1 value 53.6 kilocalorie per mole. This value you need to remember. And this is a trans olefin, that is conjugate diene. This is 59.6 kilocalorie per mole. ET1 energy of dienes, cis and trans. These two you need to remember. ET1 of cis olefin 53.6 and this is 59.6. Trans having high as compared to cis, ET1 value. So if I take cis and trans isomer, this is cis isomer value, and what about here? This is trans isomer value, trans diene. So trans diene value is 59.6, it is 53.6 kilocalorie per mole. It is energy of ET1s. ET1 of cis is 53.6, ET1 of trans is 59.6. ET1 of trans is greater than ET1 of cis. So here you write second one. Pi 2 pi star triplet reaction products. So this is triplet sensitized product. This is possible by using a triplet sensitizer. So now you will get these three products, right? What are they? Trans isomer, cis isomer, and what is one more? This one. So most commonly these two are predominate. These two are major out of these two. So this is 4-vinyl low percentage. Low percentage. Now these two will give high percentage. Maximum they will give high percentage. But this is found to be every time major. It is found to be minor. You write this reaction one more time. High percentage, low percentage. Always this is high percentage as compared to this. Very rare case it is low percentage. Maximum this is high percentage. In this cis and trans, which is major? Trans is major as compared to cis. So always remember this. Now I am going to explain this one. 4-vinyl cyclohexane. See, 4-vinyl cyclohexene percentage depends on, it is depends on ET1 of triplet sensitizer. ET1 of triplet sensitizer. 4-vinyl cyclohexene percentage. This formation always depends on which one? ET1 of triplet sensitizer. Okay, in that first one, see, if ET1 of triplet sensitizer greater than 60 kilocalorie per mole, if it is greater than 60 kilocalorie per mole, liberate approximately 4% of yield. Maximum 4. Percentage of yield is maximum 4. Very low percentage. When ET1 of triplet sensitizer value is greater than 60 kilocalorie per mole. When value is more than 60 kilocalorie per mole, means this value is very close to trans or cis. ET1 of triplet sensitizer greater than 60 kilocalorie per mole. Now cis isomer is 53, it is 59. Between these two, this more than 60 kilocalorie, very close to which one? Trans. Means now this energy transferred to trans. Trans is activated but not cis. Right or not? What is the population of trans? 95%. What is the population of cis? 5% only. Try to understand. Trans isomer 95%. Cis isomer 5% at equilibrium. But whenever if I take a triplet sensitizer ET1 value more than 60 kilocalorie per mole, now this energy is suitable for that one which having a very closer value. Between cis and trans diene 59.6, this value very close to more than 60 kilocalorie per mole. So in this 5% is there, and here it is 95% of trans isomer is there. 95% of trans isomers are start activating, start consuming this one. So when triplet sensitizer value is more than 60 kilocalorie per mole, on the time which is activated? Trans activated, but not cis. Okay. Now second one, see, if ET1 of triplet sensitizer less than 60 kilocalorie per mole, less than 60 kilocalorie per mole, that will liberate approximately maximum 40%. That is maximum 40% of yield. Which means, if it is less than 60 kilocalorie per mole, which is activated? 53. That is cis. Because see, here 59.6 means almost all 60 only. So when ET1 of triplet sensitizer value less than 60 means, now that value, this energy of triplet sensitizer transferred to cis isomer, not for trans isomer. Less than 60 means approximately equal to 59.6 only. Means value crosses 59.6, means 59.0, 59.8 like that, 58.8 like that. So now when ET1 value of triplet sensitizer less than 60 kilocalorie per mole, now this particular triplet sensitizer suitable to activate cis isomer. This particular triplet sensitizer activates cis. This kind of triplet sensitizer activate trans. If cis is activated, this percentage increases. If trans is activated, this percentage decreases. But even though this and this, whatever it may be, but final this is major. But increasing this percentage, decrease this percentage formation. See, what is the percentage of this one when I take ET1 value more than 60 kilocalorie per mole for triplet sensitizer? Here I am using triplet sensitizer or not? Why I am using triplet sensitizer? It is inefficient in pi to pi star triplet generation. So for that I am using triplet sensitizer. This reaction product percentage depends on this one only. If triplet sensitizer energy more than 60 kilocalorie per mole, then this percentage decreases, this percentage increases. Very low percentage, very high percentage. If triplet sensitizer value less than 60 kilocalorie per mole, then this percentage start increases and this percentage start decreases. But still this is major, this is minor. Even though this percentage increases, but this is minor. Because how much it is increasing? Maximum. Approximately 40, 44 like that. But very rare case it is major. I will show in which case it is major. But 99% if maximum triplet sensitizers if they given, try to give PRT for trans. Always this is minor. Forget about this one, focus on these two. So when ET1 value of triplet sensitizer more than 60 kilocalorie, now this energy transfer to activate trans isomer. And in this one, if triplet sensitizer energy less than 60 kilocalorie per mole, now energy very close to which isomer? Cis. Now that energy taken by cis isomer, cis is get excited and that will be a real participator. Right. Here population is very important. 95% population is a trans. See, when trans is activated, all trans never activate at a time. What is the population of trans in? 95. Cis in? 5%. If trans activated, trans combined with trans only. Because trans population is high. When cis activated, cis combined with trans only. Activated cis combined with ground state trans olefin or trans diene. See, activated trans combined with ground state trans. Activated trans combined with ground state trans because this population is high. See, when triplet energy more than 60 kilocalorie per mole, which is activated? Trans. What is the percentage of trans in reaction mixture? 95%. So when this trans is activated, don't think that 95% of trans activate at a time. 95% cannot activate at a time. First one trans, second trans like that, molecules keep on absorbing, one over other it is keep on exciting. S1 state is coming. When trans activated, what is the population of trans here? 95%. When one molecule of trans activated, what is the percentage here? 94% is there, one more. If one more molecule activated, 93. Which population is very high? See, if trans activated, one molecule of trans activated, this is activated trans, triplet state. What is the percentage of cis? 5%. What is the percentage of trans? What is the percentage of trans? 94. If you assume 100 molecules. In that which is activated? Trans. Whichever is activated, activated molecule combined with a 2 ground state molecule having high population. So activated trans combined with ground state trans or ground state cis? Ground state trans. Suppose if 2 trans molecules are activated, 2 trans molecules are activated, 2 are activated, then what is the percentage here? 93. It is 93. Activated trans combined with trans or cis? Trans only. This is your next topic. Okay, because if ET1 greater than 60 kilocalorie per mole, Trans activated. Activated trans combined with trans. Suppose if 60 I used, less than 60, which is activated? Cis is activated. When cis is activated, what is the percentage here initially? 5%. Here 5%. One molecule activated, 4%. But here what is the percentage? What is the percentage? 95. Now which is activated? Diene? Cis. Activated cis diene combined with cis or trans? Trans. Whichever having high population, it will combine with that partner. So finally, when trans is activated, combined with which partner? Trans. When cis is activated, combined with which partner? Trans only. That is called population effect. This is your upcoming topic. So that I can confirm how these products are measured. If you know this reason, I can explain this mechanism clearly. Why this is minor, why this is major, based on this reason only. Take them. Here you write one point. See, if ET1 of triplet sensitizer greater than 60 kilocalorie per mole, trans diene activated and combined with which one? Combined with ground state trans or not? Ground state trans diene. So trans diene combined with trans diene. Activated trans combined with ground state trans. Why? More population. So which means I can write like this. This is a trans. It is S1 state. Otherwise you can say T1 state. T1 is activated or not? It is going to combine with which one? Trans or not? What is the state of this one? These two will combine. Whenever if I am writing statement, write parallelly on that time. Otherwise you won't miss any statement. If you are, whenever if I am writing statement, if you are simply watching, definitely you are starting to lose that statement. You won't write that statement. Be careful. If I am writing statement means write parallelly. So you focus and you can listen. If you are simply sitting and if you are simply watching the statement, so I will go for next statement, I will erase this. You won't, here you are unable to write. This problem you will face in my class. Be careful. If I am writing a statement means write down parallelly. Then you feel comfortable on that time. So keep your mind on the statement what I am saying orally. Write down the statement directly. On that time you will understand directly. And you can write reaction very easily. While I am writing statement, if you are watching seriously, I will write reaction and I will go next statement. Then you don't know when to write. After completing this part, I will erase this one. You don't know whether you will write or leave. I am writing each and every point means indirectly I am saying that try to write parallelly. I won't repeat this every time I am saying the same point. So you don't know when to listen, when to write. This problem you will face. So if I am writing point directly on board means write down fastly, then it will be very easy for you. On that time focus the statement. What statement I am giving? You will understand that statement, you will understand reaction easily. So that you can complete your notes very fastly. Right, same. If ET1 of triplet sensitizer less than 60 kilocalorie per mole, cis diene activated and combined with ground state and combined with ground state trans. This is cis isomer combined with a trans. This is ground state and this is triplet state T1. Activated cis combined with ground state trans. Activated trans combined with ground state trans. If you know this point, then you can write the dimer products very easily. Your key point is triplet sensitizer value. It is more than 60 kilocalorie, less than 60 kilocalorie. Your first case, ET1 of triplet sensitizer greater than 60 kilocalorie per mole. So this is your first case. What happens if I take triplet sensitizer value more than 60 kilocalorie? ET1 of triplet sensitizer greater than 60 kilocalorie per mole. Now see, I am writing a cis isomer. Here cis isomer and here it is a trans isomer. It is S0 and here also S0. Now photochemically I am using a triplet sensitizer. Here value is what? More than 60 kilocalorie per mole. Right? Now which is activated between these two? What is the population here? 5% and here it is 95%. Which is activated? This is more than 60, means trans activated. Activated trans combined with, see, is it trans is activated or no? Now what is the state of trans? T1. Then activated trans combined with which one? Trans of ground state, like this. What is the state of T1? This molecule, what is the state? Triplet state. Triplet or not? Triplet means, see, here it is a clockwise and what is this? Here it is a clockwise. And here it is a clockwise. So this is anti-clockwise. Here I am writing clockwise. Can I? Because it is a singlet state. Which isomer? Trans. Is it trans? Trans activated combined with trans isomer. If ET1 of sensitizer more than 60, trans is activated combined with trans only. Trans activated combined with ground state trans. T1 of activated, S0 of trans. Then see this. Now if these two are combined together, anti-clockwise, clockwise. If these two combine together, you will get this two. Here this is one more like this. This is clockwise spin and what about here? Clockwise spin. What is the state? What is the state of this one? Singlet state or triplet state? Triplet state. So now here these two electrons are involved in spin-spin inversion. Spin-spin inversion takes place here. When they come close together, spin-spin inversion. So one of the electron goes opposite side, then they will combine together, you will get this product. So what is the product here? 1,2 trans. Now one more, see, if this electron combined with this one, see, this is anti-clockwise, here clockwise. Now these two electrons are combining. If these two electrons combine, now here already one clockwise spin electron is there, and here clockwise anti-clockwise double bond, and here it is clockwise. See, is these two electrons are separated by large distance or not? So when they are separated by large distance, there is no spin-spin interaction. If there is no spin-spin interaction, these two never couple together. So suppose if it is showing any spin-spin repulsion, spin-spin inversion is possible. Suppose if it is possible, then what happens? Then this electron combine together. If these two are combined together, what is your answer? See, this is double bond. Here this is double bond and this one. So what is this isomer? Can I write like this? Here double bond and this one. 4-vinyl cyclohexane. But what I am saying is this percentage is almost all 4% only. Very less percentage. Why less percentage? Why it is less percentage? See, 1, 2, 3, 4, 5, 6. 1, 6 biradical. 1, 6 biradical separated by a large distance. When they are separated by a large distance, what about spin of this 2 electron? Clockwise, clockwise. Clockwise, clockwise never combine together. They want to become anti-clockwise. One of these electrons should be anti-clockwise. When they turns into anti-clockwise, when they come close together. When 2 electrons are come close together due to same spin, when they start colliding together, one of the electron become anti-clockwise. So now these two are not colliding with each other. It is impossible to undergo spin-spin inversion. Is spin-spin inversion not possible? Can you get this? No. That's why yield is how much? Maximum approximately 4%. So these 2 electrons are two similar spin electrons are far off. They are separated by large distance. So unable to involve in coupling. Unable to involve in coupling means interaction, unable to involve in bonding interaction. So that's why percentage is very less. That's why when trans activated, trans is major. When trans activated, trans is major, and 4-vinyl cyclohexane is minor because 1, 6 biradicals are separated by a large distance. On the time, not exist. Now see, which is activated when cis and trans both are involved? See, trans is activated. Trans activated or not? When trans activated, it is combined with which partner? One more trans or not? Okay. So if it is combined with one more trans, see, initially this is S0, it is also S0. Photochemically, triplet sensitizer, more than 60 kilocalorie per mole, right? Then what happens? See, this is Vistate T1, and what about here? This is S0. So can I write directly this and this get combined together? So after combining these two, you will get this product. What about this isomer? Cis. If cis trans combine, that is different. But when trans combine, 2 products are expected. Trans and cis. So this one is major every time. Far off means they are large distance. They are separated by large distance. They are called far off. Far off electrons, nothing but electrons which are separated by large distance. They are called far off electrons. Far off. Spin-spin inversion. When 2 electrons are come close together, one of the electron undergoes spin inversion due to electron-electron repulsion. Right. So go for second one. Second possibility I am explaining directly. See this. ET1 of triplet sensitizer value, now it is less than 60 kilocalorie per mole. In last case more than, now it is less than. It is less than kilocalorie per mole. Which is activated? Cis is activated or trans is activated? Cis is activated. Cis activated and combined with which one? Trans. Because now ET1 value very close to cis isomer. Cis activated combined with trans. What is the population? 5%. 5% activated, 1 activated combined with 95. So when they combine together, now what happens? See, this electron come together now. So these two will be combined and you will get clockwise, this electron, clockwise. Both are same spin. Right? So after getting same spin, here one possibility you will get. Spin inversion. This electron come close together and they are invert together. So on that time, what is your answer? Okay, so here you may get double bond and here you will get one more double bond. Now it is a cis isomer. Cis 1,2 divinyl cyclobutane. It is a cis isomer. Now see, one of the electron is get combined together now. See this. This electron combined together now. So on that time what happens? See, here you will get double bond and here you will get clockwise and already here one electron is here which is clockwise. Is these two electrons are very close together or not? When these two electrons are very closer electrons. Now, so very closer electrons, then what happens? Spin inversion possible. Spin inversion. What happens when spin inversion possible? Now these two electrons, one of the electron goes to opposite side. Once if they undergo opposite direction, then see there is a formation of 4-vinyl cyclohexane. So then what about percentage here? Percentage is almost all 45, even you can take 45, 44 like that, it is possible. Approximately 45. So this percentage increases means automatically cis and trans percentage decreases. So here one more possibility here. If I take cis and if I take trans, now both are initially ground state. Photochemically activated, triplet sensitized energy less than 60 kilocalorie per mole. Then which is activated? Is it cis is activated or not? When cis is activated, trans will be ground state. Okay? When these two combine together, this is combined and this is combined together. Now on the time you will get a 4-membered ring and 2 double bonds are inside. If 2 double bonds are inside, your answer is what? Trans. In this which is activated? Cis activated combined with trans. Here which is activated? Cis activated combined with trans. But see, now answer is trans, answer is cis. But what it may be, trans is major, this is minor. And between these two, see, between these two competition will be there. When this percentage increases, this percentage decreases. Always trans is major. So forget about this isomer, only competition between this and this. If ET1 value less than 60 kilocalorie per mole, this percentage decreases, this percentage little increases. Right. Is it a triplet state or not? Triplet state molecule. So that's why 2 same spin electron. Now it is ground state, opposite spin. Anti-clockwise, clockwise. Clockwise, anti-clockwise combine together and forms clockwise, clockwise. These 2 clockwise will be left here if they get a new bond between them. So it is an interaction between them. So here triplet sensitizer, ET1 of triplet sensitizer, trans 1,2 divinyl cyclobutane, four vinyl cyclohexene, cis 1,2 divinyl cyclobutane. So don't write, first you listen. So I am taking some triplet sensitizers and I am writing the ET1 value, triplet sensitizer ET1 value, then I am writing percentage of trans, always cis is minor, that you write down later. So first I am writing C acetophenone, acetophenone. Okay, so ET1 value is 74 kilocalorie per mole. 74 kilocalorie per mole. over. So next, after getting this acetophenone as a triplet sensitizer, here value will be, okay, so trans isomer is almost all 78%. This is only 2%. Remaining 20% is what? Remaining 20% is cis. Okay, then here I am using benzaldehyde. Benzaldehyde, this is 71.9 kilocalorie per mole. Now this percentage is 80 and here it is 3%. Then what about this? Here 17%. Which is measured always? Trans. Later who is competing now? 4-vinyl. So when this percentage increases, automatically effect will be there on cis and trans. Okay. Then benzophenone. Benzophenone 69 kilocalorie per mole. It is almost all same, 80%. Here it is 4%. This is 4. This is 1%. And here almost all 19%. Okay. Now this percentage decreases, automatically these 2% are get affected. Next. Beta naphthaldehyde. Next is beta naphthaldehyde. So when I take beta naphthaldehyde, its value is 59.5 kilocalorie per mole. Now, so here trans percentage is little bit more effective. So here it is 71% is observed, and here it is almost all 12%. Remaining will be cis. Okay. Now alpha naphthaldehyde. Alpha naphthaldehyde. This value is 56.3 kilocalorie per mole. Now this is 62 and here it is 24%. 62, 24. Okay. Then followed by last one, that is benzyl. Here benzyl I am taking. Benzyl 53.7 kilocalorie per mole. 53.7 kilocalorie per mole. Now this is 44% and this is 4-vinyl 45%. 44, 45. Remaining what about this? It is only 1%. 40, 45, 49. Total 99 and here 1%. Means whose percentage is very less now? So which is measured in this case? If I take benzyl as a triplet sensitizer, which is measured? 4-vinyl cyclohexane, but almost all which is competing now? Trans isomer. 44, 45. We can't say it is measured. Measure means much more difference is there. What is the difference in yield? Only 1%. So that's why see it is more competitive. But every time which is measured? Trans is measured. So you remember this? See about here more than 60. First 3. Less than 60 next. So this is 7%, almost all 17, 14%. So you focus only trans, always trans is dominating. And later on 4-vinyl come over here. And that do not much more yield.